All right, let's jump right into this explainer with a pretty provocative question. Is our reliance on massive, centralized cloud servers for AI already coming to an end? For the past few years, we've just kind of accepted that serious artificial intelligence requires these massive server farms humming away miles and miles from our devices. But a new wave of research is suggesting that the ground is actually shifting right under our feet. And spoiler alert, no server farm required.
Think back to the computing revolution of the 1980s. Workloads shifted from massive mainframes to personal computers, right? And that wasn't because early PCs were suddenly faster than mainframes. It was because they finally became efficient and capable enough to meet everyday user needs, right there on your desk. Well, we are seeing the exact same paradigm shift with AI today. History is literally repeating itself. But this time, the transition is happening right in our pockets and on our laps.
Welcome to our explainer on a genuinely groundbreaking Stanford University research paper. This paper actually provides the definitive proof that the personal computing revolution for AI isn't just coming. It is happening right now. And these researchers, they didn't just speculate. They systematically tracked exactly how capable local AI has become, and they introduced a completely new way to measure it.
So, here's our roadmap for the explainer. We're going to cover the AI cloud crisis. Intelligence per watt explained. Can local AI compete? Tracking the efficiency jump. The hybrid routing solution, and finally, the future is local. Okay, let's start with part 1, the AI cloud crisis. Right now, centralized cloud providers are honestly choking under the weight of billions, even trillions of daily large language model queries. They are desperately struggling to scale their infrastructure fast enough to keep up with this insane demand. I mean, think about it. Every single time you ask a chatbot to draft a quick 2-line email, you're sending a request to a massive data center miles away. It's kind of like using a rocket ship just across the street. As the whole world adopts AI, this completely centralized approach is hitting massive power and infrastructure bottlenecks. It's just fundamentally unsustainable on a global scale.
But here's the wild part. While the cloud has been struggling, the laptops and phones sitting right in our pockets have quietly seen a staggering 126x growth in memory capacity since 2012. Thanks to innovations like unified memory on Apple's M-series chips and some really advanced local accelerators, our everyday devices can now hold AI models that are 8 to 20 billion parameters in size. This quiet hardware evolution has basically set the perfect stage for local AI to steal the spotlight.
Which brings us to section 2, intelligence per watt explained.
Okay, so think of intelligence per watt, or IPW, as the miles per gallon for AI. It's this brilliant, unified metric that tells us exactly how much smarts we are getting for every single unit of energy burned. It takes the task accuracy of a specific model and divides it by the average power consumption during inference. Now, this is a total game changer. Why? Because previously, we only ever measured raw speed or raw accuracy. Now we're directly measuring the fundamental trade-off facing our personal devices. Basically, how smart can this thing be without draining your battery in 10 minutes?
And check out the sheer scale of the study visualized here. The researchers didn't just test a handful of prompts. No, they tested 1 million real-world queries, spanning chat, reasoning, complex knowledge tasks, you name it. And they ran these across 20 state-of-the-art local models and 8 different hardware accelerators, ranging from heavy-duty NVIDIA cards all the way down to Apple's M4 Max. This represents the very first truly systematic study of local AI intelligence efficiency.
Moving on to section 3, can local AI compete?
Now, you might assume that local chips are just too weak for actual real work. Like, sure, they can auto-complete a text message, but how much of your daily AI usage can actually be processed without ever touching the cloud? Can a regular laptop really replace a multi-million-dollar data center for your daily workflows? Let's take a look.
So the crucial takeaway here is this staggering number. Small, local models can successfully answer 88.7% of everyday single-turn chat and reasoning queries, almost 90%. If you use a smart little router to select the absolute best local model for your specific prompt, that local ensemble proves to be incredibly capable. This completely shatters the old myth that you absolutely need a massive 100 billion parameter cloud model for every little thing you do.
And this really brilliantly illustrates where that 88.7% comes from. Take a look at the blue bars on the left. Local models are easily handling almost 100% of creative tasks, arts, and your everyday chat. But then, as you move over to the right, you'll see the red bars start to grow. That shows we still rely heavily on the cloud for highly technical domains, things like architecture, life sciences, complex engineering. It's a perfect visual representation of where the local capability frontier is right now.
Let's look at Section 4, Tracking the Efficiency Jump. By framing the 2023 to 2025 timeline as this compounding race between model developers and hardware manufacturers, we see a massive 5.3x jump in efficiency, and that's in just 2 years. In 2023, the state-of-the-art was the Mixtral model. By 2024, it was Llama 3.1, and now in 2025, it's GPT-OSS. Year over year, the algorithmic architectures are getting significantly smarter, and the local accelerators are delivering way more compute per watt.
So, this combination of smarter algorithms and better local accelerators means that not only is the accuracy starting to seriously rival the cloud, but the end-to-end energy efficiency per query, which is measured here as intelligence per joule, has absolutely skyrocketed by 18 times. The models are getting smaller and sharper, while the hardware is spitting out answers way faster. It's this dual engine of progress that makes local AI so incredibly viable today.
Let's transition to Section 5, the hybrid routing solution.
Now, despite all these tremendous local gains we just talked about, cloud hardware is technically still more efficient at raw processing. So how do we actually bridge the gap? Well, it leads us to this ultimate, elegant solution: hybrid routing. By using an intelligent router, your device instantly acts as a traffic cop. When you submit a prompt, the router checks its difficulty. It seamlessly handles the easy 88% of questions locally, burning practically zero power. And it only phones the massive, energy-hungry cloud servers for the truly difficult stuff, like, say, generating complex engineering code. You get the speed and the privacy of local processing, fully backed by the genius of the cloud. And the proof is right here. Notice how sharply the lines diverge. That top line? That's what happens when you send everything to the cloud. The lines below show what happens when you introduce a hybrid router. Just an 80% accurate router slashes aggregate energy consumption by 64.3% and compute costs by 59% over a 24-hour period of massive query volumes. We are literally talking about saving terawatt hours of energy globally. It gives us the absolute best of both worlds and zero sacrifice on answer quality.
Finally, Section 6, the future is local. So what does this all mean? The future isn't exclusively cloud. Man, it certainly isn't exclusively local. It is a highly optimized hybrid ecosystem. The days of sending a simple calendar request to a supercomputer in the desert, yeah, those are over. With dramatic cost and energy savings driving the entire industry, your personal devices are going to evolve into incredibly capable, autonomous AI hubs, managing your whole digital life right from your own silicon. As the Stanford researchers explicitly noted in their findings, local inference can meaningfully redistribute demand from centralized infrastructure for a substantial subset of queries. Actually, let's go a step further. This transition isn't just theoretical anymore. It is already meaningfully lifting the burden off massive data centers right now. So I'll leave you with this final provocative thought to ponder. As intelligence per watt continues to double year over year, the compounding effects are going to be staggering. What unimaginable new things will you do when your everyday laptop outsmarts the supercomputers of yesterday? Thanks for joining me for this explainer, and hey, I highly encourage you to take a look at the devices sitting around you right now. They are a whole lot smarter than you think.